Morning, Howard.
Good morning, or whatever. I guess it's the early morning, isn't it? Yeah.
What is it for you? Late morning.
It is here, coming up, approaching noon pretty fast.
Yeah.
It sounds like from your message from earlier that we need to set up a strategy, direction, rethink, maybe not rethink, but look to the world for where what we have we can apply.
Yes. Yes. It's like we've sort of been discussing we need a reboot for a while now, right? Um,
Yeah,
and
but
so I think I've certainly got enough feedback, and I'm seeing where things are going, and there are some potential companies that might be making a bit of a difference.
yeah, I think we're seeing that there are wall of compute modularity occurring in other places. Maybe not from a actual wall of compute concept, but the modularity piece is coming around.
Correct. Yeah. It
How do
certainly is.
we,
And you're seeing heterogeneity uh, blooming,
yeah,
even inside Nvidia and the like. So that's
a, a good
worthy.
indicator of a wealth of knowledge being applied to a concept. And I forget who is it that said a good idea is worth copying.
There you go.
If maybe copying wasn't the word, or taken advantage of, or learned from, or something, right?
Yeah, yeah.
Yeah, I had in my old office when I was development engineering manager or whatever, I had a old skate from 50 years ago,
Uh-huh.
roller skate, and I had a skateboard, and I had inline skates, one of each. So nobody would take them and roll them around the factory. Um, but how do we pick something that is a change in the world, somebody else's change, take advantage of it, and the roller skate becomes a skateboard, becomes a roller blade, becomes a success.
Right,
Uh, so how do we draw from all these other ideas and pull out the pieces that apply, whether the modularity, whether it's cooling, whether it's, something. We have to find that winning piece, whether it turns out to be urethane wheels on a skateboard to become urethane wheels on a rollerblade. But there's a piece of what's going on that I think we can take advantage of, and I just don't know what it is.
right, right. No, well, as we go through, I'm sort of solidifying my perspective around all this in terms of an actionable way we might be able to go forward. So it's my attempt at trying to narrow down our focus to what to do next and maybe find a potential funding avenue. So that's what I'm hoping to cover today. But
But it's more than just a funding avenue, which of course we would need, but
yeah,
it's also a piece of unfair advantage. How can what tool do we have in our ideas that gives us an unfair advantage?
right,
Um,
right,
it doesn't have to be unfair. It just has to be a good idea whose time has come, right? Somebody else's quote.
yeah, yeah. I think that's where we're um, I mean, I think that's where we got some challenges, right? Because things are so rapidly changing. Um,
That's an advantage as well.
yeah, but in terms of we're trying to get standardization, and you're chasing things that are changing too quickly. So um, we it's I think yeah. It's can we catch? Um, it's a standardization game. Can we catch interoperability is the key thing? Whereas everybody else, all the big boys are vertically stacked, and we need to embrace the something where we can all leverage so that we can combine people's different companies' best in class expertise into a best in class industry standard. And so obviously there's lots of things going on there, and that's the trouble. Is which one do you pick? I think is a or if you can stay flexible like we've always tried to be, then that's obviously can be a bonus. Yeah, it's lots to discuss here for sure.
And
Let's
there's historical things that have occurred that we all can learn from, whether it's the original IBM PC that was open source and the Apple, which was not. And uh, then how do we take advantage of all the world's resources for software and hardware and not put ourselves in an Apple position where they struggled for long and IBM has thrived with its PC. And then, of course, things have changed for IBM, but um, what history can we learn from that we can take advantage of so that we can have a winning combination? And it may mean relinquishing a lot of control to everybody else in the world and having a commonality, whether if you think about what we have today in uh, card edge connectors, being a connector guy, the original microchannel card edge is now MCIO and PCIe and and instead of plugging your sound card and your whatever your video card in, we're using it to communicate at gigabit speeds. The same old connector left over because my history, of course, is in that microchannel connector. But now it has leapt into applications. It's ubiquitous,
right,
left over from
right,
IBM PC days.
yeah, yes. Well, therein lies the challenge. Um, all right, we're just having me and Howard have been just chatting. We've not officially started here, guys, but good conversation, which is very relevant to what we are going to be talking about. So, Howard, feel free to jump back in as I go through these my perspective. So just capture and welcome everybody. I'm just capturing the attendees. It looks like we might have a couple of new people. So in a moment, I will ask for introductions, if possible. I'm running a little bit late myself, so let me uh, just get myself sorted here a moment. All right. Right. So I presume most of you have seen the message I sent out last night. Apologies for the delay on that. So yeah, today really my action or my hope for today's discussion was for us to, we've obviously been discussing lots of ideas of the state of the industry and where are we going as a group. Is the HPCM wall of compute still applicable to today, or what tweaks can we do? And I think we've generally concluded that the core principles of where we started and came up with the HPCM solution are still absolutely identical. We said number one priority was energy efficiency, and I guess number two is cost, and obviously performance is like a given. That's for, in fact, the energy. Everyone just talks about energy now, so we were absolutely right to focus on that, and energy efficiency, and then sustainability and energy reuse are the other facets of that. So anyway, we've sort of seen how NVIDIA have progressed, how AMD have progressed, how other startups have progressed with their inference solutions. And I think a lot of it is just, we're seeing heterogeneity really become absolutely solid now. Even within the individual companies like NVIDIA, they're going heterogeneous crazy right now. And so, again, that was a core modularity, heterogeneity, where the modularity would be that we can mix and match from lots of different players. That's obviously a lot more challenging in the stovepiped, vertically integrated, because they're in control of everything, and you don't have interoperability challenges. So I think the premise of where we started is still the same. But the reality of where we got to was that we got to the point where we had a proposal into Oak Ridge National Labs New Frontiers funding program, which sadly got cancelled middle of last year sometime. And it got cancelled middle of last year sometime, and so we sort of went a bit rudderless there. But now we're seeing new government initiatives where potentially we could find new funding, and so it might be worthy of us exploring that. So that could give us some funding possibilities. But also, I think we're seeing a number of companies that are beginning to make some interesting traction that is, again, aligned with some of our thinking. So I think that's quite an interesting perspective as well. So I want to cover that today. I've rapidly pulled a couple of slides together to just sort of go over that and encourage debate, discussion. What do you think of the ideas I'm proposing? They're fairly high level still at the moment, but they're trying to give us some focus. Anyway, before we get started, let me just, we do have, we do have a couple of new members, I believe, on the call. So if you guys could briefly introduce yourselves, that would be good. So I see a Joe and a Joe Wu. I don't know if you're two different people or the same person dialed in twice. Okay, so Joe Wu, would you like to start? And are you the other Joe as well?
I'm not sure. Can you hear my voice?
Yes, I can, Joe. So just a quick introduction of yourself. Your name, what it is your expertise is in, who you work for, and what you're interested in, what we're up to.
Okay, great. Okay, this is Joe speaking. I'm coming from Taiwan right now. Okay, I work in Taiwan, a system company. We are doing the server, especially right now because of AI. So we design the MHS, the motherboard HPM, and also combine into the system and including the whole rack solutions. So I joined the industry for server about 15 years, yeah, as a designer. Right now, I'm handling to be a developer managers. Yep. Thank you.
Okay, thanks, Joe. Are you also the other Joe, or is that another Joe there? If you can say hi, the other Joe.
Yeah, my first time, yes, here.
So hang on a minute. So which Joe was that? Was that Joe Wu?
Yeah, I just said I'm Joe. Yes, from Taiwan.
Right. So you
Yep.
appear to be logged in twice. Okay, so
Hey,
you are.
Alan, they're the
Oh,
same person. Yeah.
I see. Because using
Okay.
the computer, I have no voice from computer. I joined, yeah,
No,
twice.
that's fine. That's
Yep.
perfect. No worries, Joe. I
Yep.
just need to. Right, and Gaurav, I think it's your first time.
Hi, Alan. Yes, thanks for the floor. It is my first time. I have previously looked at some of the research, but first time participating in the call. So quick intro on myself, based in Boston, work in Aptiv, and I'm part of the corporate strategy team. And my main purpose to be here is to understand where the market is actually headed, because we see a lot of conflicting information at times, and just to get a clearer view from a technical perspective on where the market is going, how to plug in, and then also, just learn from the best. OCP is on the forefront of many of the innovations, and it's left to be in the ecosystem.
Okay, welcome aboard. Thanks, Gaurav. And oh, sorry, Joe. Did you? Can you give us the name of the company you're with, Joe?
And me,
Yeah.
Pegatron.
Oh, you're Pegatron. Okay, yeah. I've talked to you
Yep.
guys before. Okay, great. Well, thank you for joining. Both of you. Hang on a minute. I'm just trying to sort out my Pegatron. Excellent. Okay. All right. Well, thank you, and hi to all the new people. Let me. Sorry, I'm a little bit disorganized this morning, as I said. Just sort out my crazy, messy desktop. All right. Okay, so now I will share my screen. Mitch. No problem, Mitch. I'm just listening in. Hey, Bijan, and hi, Hisham. See, you've just joined us. Let me just capture you two.
Yeah, apologies. Had a call that went too long, so a little bit late.
You've just missed introductions, so you won't miss too much, and a bit of gassing between me and Howard, which was good actually. All right. Okay, I'll update that shortly. Right, let me share my screen. Okay. You should be able to see this. Can you see a full screen of proposed plan for this year's OCP HPC focus?
Yes.
Yes.
Okay, great. All right, as I said, that's so here are some ideas from me. So, like I said, we've sort of been kicking around ideas over the last few months, and as the industry has moved forward quite rapidly, and so the idea now is I think we've explored various discussions and ideas and how do we want to move forward. So I think, like I said earlier, we've the HPCM wall of compute was very applicable, and the core principles of why and how we created it remain the same, and in fact got even stronger, especially from an energy efficiency perspective. So it's like, can we narrow the focus of our HPCM implementation with certain targets and constraints, a bit like we did for the New Frontiers proposal. But maybe we need to, or maybe that we have an opportunity to now the crystal ball is a little bit clearer, or at least a few years forward from when we did that originally. We may want to tweak some of those parameters, and in that we may have some potential new development partners that we could approach, if this would help them in an enablement way of what they're trying to do, and if they're prepared to work in an open ecosystem in at least some capacity. And finally, identify some government funding avenues to explore. Obviously, there's been a massive disruption in funding channels. The OE was pretty much completely defunded, and now we've got this rather depressingly named Department of War. But that's where it looks like plenty of funding could potentially come aligned. So maybe we should start to explore those avenues a bit more as well. So that's the topics for today. So on the narrow inner focus of our HPM implementation, I'm sort of at the moment, and again, I'm not hard on this, but when we look at what we're trying to build, obviously the wall of compute was just so radical, rebuild the data center itself entirely. And it clearly threw a lot of people off, said this guy is crazy or this group's crazy, which, but it was, if we had a clean sheet of paper, that was the whole principle. We came up with a nice implementation of that with Carno, with their liquid cooled chassis, their custom designed liquid cooled chassis to support 32 of our modules for the proof of concept. So that was quite a nice narrowing down there. And I guess you could see their implementation as a sort of an edge system. And so, in terms of the crawl, walk, run, I think maybe edge systems, there is an opportunity there, especially from a cooling perspective and an energy reuse perspective in more of a local fence. If you've got edge systems, you might be able to more easily and locally reuse the energy, the heat from the cooling infrastructure. So, can we design it to actually integrate with the edge infrastructure? So maybe it doesn't look like a 19-inch rack, or maybe it does, or an ORV3 rack. So, or maybe it's not a drawer, maybe it is a blade, maybe it's not a blade. But if we focus on edge systems with specific use cases or specific infrastructure compatibility, then that might be a way for us to narrow our focus. Obviously, if you're at the last call, I was talking about water cooling again. I leveraged AI to give me a bit more expertise in the area. Not saying I'm so stupid in my ideas, and I have a free thermal engineer in terms of AI in terms of a level of expertise that can keep me on the straight and narrow and tell me what's absolutely stupid. We've obviously been looking at attempting to enable two-phase cooling, or if we can reduce our energy density, with the introduction of optics, etc. By design, then maybe single-phase water would still work. So that would simplify things compared to the two-phase water cooling. But the key thing would be they would focus on a high temperature in the order of 65 degrees C outlet for energy reuse purposes. So a high quality energy reuse purposes. We've often talked about chiplet enablement with our HPCM, and that seems to be getting to a stage of maturity where we're seeing chiplets come to enablement, whether it's the big boy chiplets in the likes of UCIe or a few other custom implementations with the likes of Bunch of Wires and Tenstorrent, I think, are one of those that have adopted that, or other ones like companies like Credo that have been doing their own chiplet strategy. So we're seeing reality come, and it's whether we could adopt some of that going forward. So I think that double down on the chiplet enablement, because I think in terms of a standardized ecosystem, giving ourselves, if companies can build chiplets in an ecosystem and we can all reuse them, that could bring some tremendous benefits. And there is an angle on the chiplet. Those of you that if they've listened to me drone on over the last 3 or 4 years or 5 years or 6 or 7 on chiplets, I'm very much of a standard IO for all processors, so that you can easily swap anybody's processor with anyone else's. This IO where you have different IOs for memory and different types of IO for scale up and scale out and et cetera, et cetera. Obviously, I'm a big fan of a single IO strategy, which I've been very vocal on. And so that sort of fits in with the chiplet enablement from my perspective. And interestingly, I think one of the, I've got here still cable focused, supporting both copper and optical. But I think we're now shifting gears where optical should become our priority thinking, but not necessarily the only, not necessarily dropping copper completely. But I guess what's interesting, if you see what the large guys are doing, especially NVIDIA with their Vera Rubin architectures, they had lots of copper cables in the Blackwell B200 and B300 implementations, but their Vera Rubin version of the same tray level approach, they've tried to get rid of as many cables as possible, and have gone back to PCB traces with, I guess, very clever and efficient use to get the signals to reach through the substandard PCB traces. And I think there's some big claims that their manufacturing time or cost of the servers of each node is actually come down like 60 or 80% or more. So the cost, so they're highlighting that the cost and the quality reliability issues of cables is a big deal in the manufacturing, and it's difficult, I guess, to get robotic assembly of cables, etc. So clearly that is an issue. But having said that, I think that this may be still a need in an industry standard approach where we can interconnect different people. If we're going very modular, then a cable in between different companies' modules would be ideal. I think that optical could become more reliable and a lot less dense, obviously. And so that's why I'm saying let's focus on the optical priority. So that would include near package active optical cables, including micro LED or photonic solutions, and optical interposer implementations like shout out to Bijan, Light Matters implementation. So that's really my view of how we would sort of refocus our energy. Any comments on any of that in terms of what I'm saying there? Anything I've missed? Anything you disagree with?
I think one thing that might be helpful, just thinking out loud, this might be totally off base, but it might be good to define what HPC is in terms of density, maybe. Whether that be
Right.
compute density or I don't know, infrastructure density or something like that. Just so there's a clear delineation in our minds, like, what we're doing for AI systems today, and then what we want to do for HPC moving forward. Because I do think there's a difference. And I think if you don't maintain those boundaries, it becomes blurry, like what you're working on, and you start questioning, like, why am I doing this?
Right. So density is it's got two factors, right? Obviously we're going extremely dense today because of the reach and the extra energy required to reach further, you know, well, yeah. So so therefore our energy density is going through the roof, and we're getting, you know, 100 and, well, it looks like we're approaching megawatt racks on people's roadmaps. The flip side there is that optical, low energy optical connections could have the potential, big C and could have the potential to reduce the energy of moving data over slightly further distances, which could address the energy density part of the equation. Hence, do we really need to go to two-phase with water? Could we just say single phase, for example? But we've also got the question of density from a latency perspective over distance. Obviously, we're talking a nanosecond per foot. So we've got a fair bit to play with there. But in terms of, we could decouple density quite a lot, but obviously that is the other side of the equation in terms of overall latency of the system. So yeah, I agree that we do want to define it. In my mind, to be honest with you, Bijan, in fact, my biggest problem that I've got in my mind is, if you look at where we're going, if we're trying to design one solution for as a standard for our industry, if you look at what's going on between NVIDIA, AMD, and companies like Tesla with their Dojo, or Cerebras with their wafer scale stuff, both of them, you can see that there are roadmaps to go to wafer scale type assemblies, whether they're, you know, reconstructed with RDLs, or whether they're out of one wafer like Cerebras. And if you look at what NVIDIA are doing, they're now at 4 reticule size in Rubin Ultra, with IO dies and 16 HBMs. So they're getting absolutely massive as a module, all within the one package. And if we look back, you know, OAM was a sort of size, or SXM from NVIDIA, but these are having to grow now, the way they're doing these. So we want modularization for heterogeneity and reconfigurability of the heterogeneous implementations. So in my mind, it's a case of, we really probably need to constrain ourselves to a mechanical size that's reasonable, where you could get a lot of modules tightly packed together, but you have flexibility of the heterogeneous configuration. And so, you know, I've been trying to get my head around, could we design an approach where you could you could have a wafer scale in one implementation and a small module in another, and I can't get my head around that with it being a fairly straightforward standard. So I'm sort of favoring going down to like single reticule size, full reticule size plus chiplets, IO type chiplets, being our sort of staple, so to speak, and then hopefully low energy optical interconnects would give us the ability to couple dies together at extremely large bandwidths without them needing to be stacked next to each other, reticule to reticule, full reticule size to full reticule size die. Does that make any sense, or am I missing your point, Bijan?
No, I think that's helpful. Yeah, no, I think that's helpful. I don't know that it fully, I mean, I think we can go a little further, and set what the goalposts are, because, you know, maybe there are things that we haven't even, you know, kind of touched on because we don't know how far we have left to go.
Right. I think the unification, by the way, of just into one module format, you know, be it a network IO card, a switch, an optical circuit switch, a light matter device with optical substrates. I think if we can just get to one module format where as a systems engineer, I can construct any machine I want out of any mix and match of memory, switches, processors, accelerators. That's what we want to be able to do. But that, by definition, that means you don't want to be too crazy large with the individual modules. But obviously, the smaller you are with the modules, the more you need to interconnect, the more cables you need, and then the more the point of assembling these systems becomes more complex. But if you bring if a fully customized heterogeneous machine for a particular application, be it HPC, AI, or a mix of the above, et cetera, if the very focused domain-specific build of that system brings you 100x performance improvement over a vanilla NVIDIA machine or a vanilla HPC machine, then maybe the hand building of these nodes is not so much of a problem, because and they serve smaller markets as well. So customization for smaller markets. So again, I'm not saying I have the answer. I'm just saying I've been trying to square that circle, and that's been a bit tough. So I'm happy to beat it around a bit more. In fact, I think the footprint, the system level footprint, is pretty critical. But if we go for this modular approach and we start with edge systems, there's no reason why we couldn't scale to a wall of compute approach, like we were previously at. But let's not worry too much about the mega systems right now. Any other comments? Okay. All right, so potential development partners. So I just wanted to list here. So on the right, this is the partners that participated in the proposal for the New Frontiers proposal that we put forward. Carnot Computing, we're doing the thermal management in the chassis. Luminaire, we're doing the HPCM module design and build. Lattice Semiconductor, we're helping us with the BMC and the overall system management considerations. Amphenol and Lotz were on the interconnect side, mainly electrical. Light Intelligence on the optical. Avicen on the micro LED, and Jabil on the system manufacturer. So that was a nice collaboration of companies there in our proposal. I've added a few that have, I guess, inspired me over the last couple of years. So potential new partners, RISE Institute, that's a research institute of Sweden. John Summers is a key guy there running that effort. And in fact, he was the chair of the Future Technologies Symposium last year. And so he's got a very good thermal lab especially in terms of energy reuse, etc., up in North Sweden. So then he's been very good. Him and his team have been very good at helping me think through various ideas. I'm also very impressed with a company called Strategic Thermal Labs. I saw that the CEO Austin presented supercomputing a couple of years ago, and they seem to be a bit more radical in their thinking as well. And I think that maybe they would be able to help with some of the crazy water ideas that obviously I can only take so far as a systems guy. Then Credo, so apologies to the companies that see them as a competition or partners, I don't know. But Credo are an interconnect company that have seem to be very successfully transferring into being a semiconductor company specifically focused on chiplets, but their real focus is on disaggregating the interconnect, getting rid of the stupid IEEE approach and actually saying, let's save the energy in the I/O and increase the I/O density. So I'll touch a little bit more on them. The reason I really like them is everything I was pushing in the Open CAPI consortium when I was a technical director there, pushing the open memory interface, they are making in reality a version of the OMI and this one unified I/O, chiplet I/O on the silicon, and then converting to I/O or memory through chiplets. And so they're effectively executing what I've been arguing for the last near decade, I'd say. So whether they picked up on what we were doing here and said, that's a good idea, let's make it happen, or whether it's entirely their own ideas, I don't know. And another interesting thing is they're working with an AI silicon startup that started with FPGAs, actually a company called Positron. And one of the things I was pushing back when I was at part of Molex, in my Nalatech days, was we could implement an FPGA accelerator with massive memory and pretty serious bandwidth at the time anyway, with the OMI memories. And I was trying to develop a card, which I said this is the biggest no-brainer compute FPGA card with lots of memory capacity and bandwidth for AI. It's the biggest no-brainer FPGA card I invented, I guess, since I started my Nalatech days. But sadly, I couldn't convince the people in charge in those days. Well, Positron started with AI inference in the FPGA and seemed to be making pretty good progress. Funnily enough, they are using Bitware's or Nalatech, what used to be Nalatech's cards for their FPGA accelerators. And they are now partnering with Credo on their memory, on their OMI memory buffer equivalent. So they're bringing very large capacity memory to an AI inference accelerator. So that's very interesting to me with my experience historically. So I've got a little bit of a soft spot for these guys. Now, their interconnect is proprietary today, but they are pretty active in OCP. So I'm hoping to help with others, convince them to open up their chiplet standard. And then Bijan can talk to this, but like Matter, they've got their photonic interposers. So it seems like that might be another interesting avenue. So maybe if we can build a module, if we come up with a module standard, we could do a module with like Matter as well. So that would be obviously be a different approach to the Credo implementation, and pretty much 100%.
Heck no, I'm proposing an open standard.
Good. Even better. So those are the potential new partners. I'm open to more. None of these have been spoken to. They're just, I have no idea whether they'd be at all interested, except for Bijan. Again, he's just said it is open, so hopefully we can get something going with you, Bijan. So that's just my thinking right now. If there's others, please shout out. Or any other comments. Okay. The other thing is I think if we can get some of these involved, I think that we might be able to get either some level of funding for them or a lot more credibility in our proposals to the governments to actually get funding. Okay, so that's that. Just because as you probably just realized, I'm pretty hot on Credo and the Positron demonstrator. This is their approach. I have shown this before, so apologies if I'm boring you. But you've got your accelerator processor. They have what they call their OmniConnect. So your processor will only have one type of I/O, nothing else, just their OmniConnect. And I was just listening to one of their presentations, and they were just saying, because it's really low energy compared to your normal I/Os on these devices, and they can fit, it was some gargantuan number of transceivers around a maximum reticule size. Shame I can't remember the number. Which was exactly a presentation that I was doing when of how many of the OMI channels could you fit around an XPU. So it's almost like a carbon copy of the presentations I was giving years ago. You can connect your XPUs together in a die-to-die form. If you use this I/O, that's one of them, and they're showing that. You can see they've got this new memory weaver chip, which you will see that Positron are using, is actually been announced and available, becoming available. They've already got their scale-out approach with their active electrical cables. Well, I'm not sure if I think the active electrical cables just talk standard long reach at the moment to the system for obvious reasons, but I think they have lower power ones that will talk to their OmniConnect, and they could potentially do scale up that way as well. And then they have a competitive solution to Avicenna. They've acquired a micro LED company for near packaged optics, so an LED version which is very low power. So this is, and I've been pushing this as well to the chiplet work group, what used to be the ODSA, the open chiplet economy. And obviously, again, this means that we need to convince Credo to fully open OmniConnect. So that's the fly in the ointment there, shall we say. Just a little bit of information on the OmniConnect. They had an extremely short reach, 112 gig and 9 dB. They've now introduced a very short reach to go up to 250 millimeters, or roughly 10 inches, up around a picojoule per bit, and 2 terabits per millimeter on the beachfront. So you can do your terabit calculations for your beachfront of a 35 millimeter by 26 roughly is your reticle size. So 35, 70 plus 50, 120. So 240 terabits of bandwidth, if I did my math correctly. And they've done a little comparison of different SerDeses that you have today. Looks like they're being very generous to PCI, saying 3 picojoules per bit. But maybe I'm not up to date with the speeds. And you can see what they've got there. So that's a little bit on the phi layer of their I/O. I believe so. So what they're doing is VSR means that you can still have your single monolithic die in a package, and you can connect in very short reach off package to a connector and go with your active cables, I guess. But if you go into a chiplet implementation, then you could use their XSR ones and I'm not sure what how much power saving you get on their 9 dB XSR channels, but that could be a potential tweak on the OmniConnect implementation. Any questions there? These aren't my slides, so I can't give detailed answers. This is their implementation. Lightweight AXI framer. What if we gutted CXL to its bare bones? Oh my God, what goes around comes around. OpenCAPI was just point-to-point, forget all the switches. OMI was a stripped-down OpenCAPI to really get to the latency. And now we're seeing people gut CXL to go in the same direction. It was 2018, and it looks like it'll be 10 years for us to get back to it as an industry. So sad we didn't go with OMI in the first place. But anyway, sorry, that's me just so they're saying keep the flit structure of CXL, and there are a bunch of other things here. And they're on about creating the most efficient AXI. So they're trying to maintain the AXI bus effectively, but across chiplets. And they've got this 40 nanosecond target. So it's quite a bit longer latency than OMI was, less than 10 nanoseconds, but nonetheless considerably better than native CXL. And this could be folded in is a subset interconnect of CXL as well, rather than the rather heavy and multi-protocol UCIe. The beauty here is these guys are making these things for real, so it's not a paper study. It's actually happening, which is my biggest interest. And here's Positron, which are the AI silicon company. That's their chip in the middle, their Asimov AI accelerator. And they're trying to connect as many of these Weaver memory, LPDDR3 memories together and go to a cashless, a memory optimized implementation. So you've got much more capacity, and they're talking about some serious bandwidths. I've not. There are other slides that will talk about the bandwidth you can get to. You can sort of knock on the door of HBM bandwidths, but with pluggable modules, there will be a power penalty for sure compared to HBM, obviously, because they are still at a picojoule per bit there compared to HBM's sub half a picojoule or sub quarter of a picojoule per bit for the I/O. So there will be an overhead there, but there will be a flexibility and a much larger capacity configuration and more capacity depth. Okay, so that's that on Credo and why I'm hot and heavy on what they're doing. From the government funding, so hands up, I asked AI to help me out with what the hell's going on with the government funding. So this is from Google Gemini, a lot of this intelligence I've got. But really, we've gone from peacetime science fairs that DOE sort of represented to this wartime arms race and sort of an AI arms race, so to speak. So there's potentially 3 new opportunity areas within this the funding that's coming out of the government now, where we could pivot our New Frontiers proposal. They've got this speed to power. This is the macro pivot, as they've called it, that we could go down. And I'll touch on each of these in a moment. So, but it's much more at the infrastructure level, that one is. So we need to look at the applicability to us. There's this Genesis mission, which is the compute pivot. And there's this Office of Strategic Capital, which could be the silicon pivot. So we could possibly operate in one of those last 2. If we look at the speed to power, the macro pivot, so the initiative is primarily managed by the Grid Deployment Office. So the goal is to solve the power wall problem for AI by building 3 gigawatt to 20 gigawatts of capacity. This is really a mismatch for us, as far as I can tell, mainly focused on transmission substations and baseload generation. So we're very much sort of at the rack level or inside the data center. So I think we might brush what they're doing here at the DC stuff level, but it's really more of a heavy industries play. So that's not for us. Then we've got the Genesis mission, what they call the compute pivot. So it's people liken this one to the New Manhattan Project. It's where the DOE has consolidated its AI science and high performance computing efforts. So the potential fit here is apparently the mission is desperate for hardware efficiency, which are obviously which OCP clearly champions, because they're training massive scientific foundation models. They need an open architecture that provides to avoid vendor locking with proprietary stacks that are becoming increasingly expensive and power hungry. And our work on open ecosystems for AI and HPC compute is a direct answer to their need for American-made efficient stacks. So that's a possible avenue. And the other one, this Office of Strategic Capital, which may actually be the best in my first pass opinion, at least. So Secretary Hegseth mentioned tapping into hundreds of billions in private capital. The OSC is a bridge for hardware companies, is what it's describing it as. So the potential fit for us is our systems architecture, hardware semiconductor focus aligns with OSC. That's designed to provide patient capital to hardware firms that don't fit the traditional VC model. Well, that's definitely us. And Hegseth's wartime angle is he explicitly stated the Department of War wants to build computing power on its own military installations. They need OCP-style modularity and efficiency so they can deploy these in remote and tactical edge environments where power is scarce. And so that one sort of plays to, really, if we just focused on an edge implementation first, not with exclusivity to not being able to ramp up to a data center scale, because if we have this modularity, I think we would be able to, but that would allow us to contain the system architecture and the cooling architecture a bit more reasonably in the project efforts. So that's pretty much it. That's my thinking as of now. Any comments, feedback, concerns, missing something? Happy to hear all of the above. Bad idea, great idea. So.
When do we start and when do we finish?
That's a good question. I think, well, I'm sort of ready to start now. I personally think, in fact, you specifically, Bijan, and Credo are my two sort of areas of, and the thermal guys are my areas of. Would you guys be interested? Your commercial realities, all of you, and albeit maybe slightly restricted or maybe not so restricted startups. Although Credo is pretty well established and doing well. So can we get interested from people that could make a difference to this? Like the chipletization, the I/O side, the optical enablement, the thermal management, the water approach. If we can bring those pieces together with people that are credible, because obviously I'm not really credible in any of these, then I think that would be a good start of, well, we could put something forward to the government. In parallel with that, it's identifying what funding avenues there are in the government. I am connected to somebody that is actually been heavily involved and has funding avenues that have been enabled for a while, but it's taken just approved and waiting for the funding to come through. So that funding is now coming through, and he did say to me, he had me penciled in for as a potential consultant helping them out. But he did say the big ramp up, they're trying to accelerate federal efforts, mainly by going through Texas, because Texas is a bit more dynamic. So he said probably projects will kick off fastest that are based out of Texas. Like fastest as in immediately, whereas if you're in different states, he thought that might still be 6 months or a year away from kicking off projects in different states because of various federal bureaucracy. So I'm not sure if you're based down there or you're based in Silicon Valley, Bijan, but or if we could kick off, or if we got offices down there, but we could kick.
It's a lucky day. We've got you covered both ways.
All right, there you go. So does that answer your question? I think we can get going fast. I mean, look, I'm a volunteer here. I put in. I've got plenty of things to do myself. I've got plenty of fun projects. I enjoy doing this, but we got to.
Yeah, I think if we look at what you guys have done, what you've done so far, and it's been very impressive. I think what we have to do, we have to make sure we do this time is to align with the industry roadmap and timelines, right?
Right.
So that's why I was asking the question, because we just need to make sure that we are embarking down some path that it kind of lands somewhere at a time where the market needs it. And
right.
That was my only concern. I'm looking forward to kind of kicking this off and getting it going.
Yeah, no, fair enough. I think the urgency of this Department of War and the this Office of Strategic Capital is an interesting one in terms of, I like the way they said patient, was it patient capital, was it? Yeah, patient capital compared to VCs. We're trying to bring standards together. It's invariably slightly slower. Not that we can't make fast progress, and targeting certain edge military applications, so that would be quite interesting that the actual system level footprint could fit a particular military use case potentially is our starting POC, so to speak. So I don't know, it feels like there could be something that you could get your arms around that would be funded quite quickly and we could get going on. In terms of convincing NVIDIA or AMD, I've given up on those. In terms of convincing AI silicon startups, I've now consulted for several. They're too busy staring at their navel of their silicon to really realize how they're going to compete at the massive scale when they actually have a fantastic chip to really compete with NVIDIA. I'm sure they would all jump on the bandwagon if it was already established. That's where if Credo works with already having positron is a startup using their approach, and they could be a good lighthouse startup to say, this is good for us, and maybe we could pull them in. And Credo is also a heavy OCP participant and very plugged into the hyperscalers. So I don't know if this can map onto what the hyperscalers are doing with their own silicon, and whether they have an interest at the edge. I'm sure they do. I'm sure government would twist their arms that they need to be delivering at the edge as well. So I don't know. It feels like we do have an opportunity. We do need motivated people that believe there's a commercial opportunity at the end of the tunnel. I mean, I'm a techie. I mean, I'm not being paid for any of this the last 5 years. So it's not the money that motivates me, but although that would help. So yeah, that's my sort of general view. Any other comments? Howard, you were fairly vocal when we were kicking off. Does this ring at all with what we were discussing earlier, or have I missed the point completely of what you were making?
No, I don't have as broad a perspective as you and Bijan have on this whole thing. Being an interconnect guy, this is a bit over my head, but I'm all for innovation and running us away from the incredible energy, heat, space, all that's involved in our current data center problems. I would truly love to see some innovation occur that takes away some of the pain that our communities are having for data centers moving in. And if this can be one of those things, it may be what it takes to make a difference.
Okay, sounds good. Thanks.
All right, I gotta drop. Bye, everyone.
Yeah, it's 9 o'clock. That's good. Thanks for. I've seen the comments. So thanks, Joe, and thanks, Gaurav. We'll reconvene in a couple of weeks. I'll see if I can nudge a few of these forward at all and give you an update in a couple of weeks. Thanks, everybody.